In this episode, we're going to implement the join and leave mechanisms of the game, and we're also going to use Lombok to refactor our code a little bit. If you didn't know, Lombok is a library that you can use to eliminate boilerplate code like this, so you can get rid of getters, setters, and constructors. For example, if you want to get rid of getters, you can simply annotate the attributes that you want to create a getter for with @getter. Then make sure to add Lombok to class path and import getter. Then you can also do it to this attribute and to the age attribute as well. And if you have something like this where you have created getters for every single attribute that you have in your class, you can also just remove them from here and do a class scoped getter annotation. Then we can get rid of the getter methods, and as you can see, they are not visible, but they do still exist. So you can type get here and see all the methods that are still there. And the same for setAge. We only want to create a setter for the age variable, so we're only going to annotate this attribute with @setter, and then you can get rid of this method. If you have a constructor like this, where you expect every single field that you have created in your class, you can also do that with Lombok with the @all_args constructor annotation. And this is how the class looks after you have refactored it with Lombok. And we're going to do this kind of refactoring to our games class, because you can see we have quite a lot of getters and setters here. So let's create the getters first with @getter, then remove them. And now we're going to create the setters. As you can see, we have only a setLocations and setID method. So let's annotate the ID with setter and the locations @setter. Then you can remove them as well. And now the constructor is a little bit more complicated, because as you can see, we don't have a constructor with all the attributes of our class. We only have a few. We only have the name and the settings, but there's a little workaround for that. In Lombok, we have a required args constructor, which creates a constructor for all the final fields. And as you can see, name and settings are final. We only need to make the players unfinal, and then we have exactly the constructor that we wanted. So now we can remove this, and this fixes the error above. And now we can start with the join logic. So inside the game method, create a package private join method with void join. We expect a player. And then in this series here, I want to use an event-driven approach. So for every significant action that happens in game, for example, joining or attempting to join, I want to create an event. And then for each of those events, we're going to create an event listener. And in those listeners, we will handle the logic. So for the joining, we will have 2 events, a player attempt join game event, which will be cancelable, and a regular player game join event. First, we want to create the player attempt join game event. So create a new package for that, call it events, and create the event class. Player attempt join game event. This will extend from a class called game events, not this one. We will create a custom one for that. So inside the events package, create a new class, game event, and this game event class extends from player event. Then create the constructor and implement the methods. For the constructor, make sure to change this from protected to public. And then, as in any custom event, we need to create a few methods and fields for our handler list. So private static final handler list, call it handler list, and this is equal to new handler list. Then return the handler list here, and also create a static method. Now in the game event, we not only want to expect a player argument, but also a game argument. Then create an attribute for that, private final game, and a getter with Lombok, for example. And inside the constructor, assign the game variable. This.game is equal to game. Then in the player attempt join game event, create the constructor, and since this is the player attempt join game event, we want to have a possibility to cancel this event to prevent a player from joining a game. For example, if the game has already started or if the game is full. So for that, implement cancelable, implement the methods, and create a class scoped variable to keep track of the cancel state. So private boolean cancel. Then inside this method, return it, and inside here, assign it. This.cancel is equal to cancel. And now in the game class, in our join method, we're going to create a new player attempt join game instance, player attempt join game instance, attempt join event, and this is equal to new player attempt join game event, as a player passed player and as the game passed this. And now we need to call the event so that event handlers and other plugins can listen for it and manipulate it. And you do that with bucket get plugin manager, call event, and simply pass the event object. Then after we've called the event, we want to check if any event handler has cancelled it. So if not attempt join event is cancelled, this means that no event handler has cancelled it and the player can join. We want to manipulate the players set, this one, to add the player. So this.players.add new game player, player. And let's actually rename that from game players to game player. You can do that by clicking on it and pressing Shift F6 and then just type the new name. And this changes it in every location. Then after that, after the player has successfully joined the game, we want to call another event, the player join game event. So let's create it, player join game event. This extends from game event, of course, create the constructor and call it here with bucket get plugin manager call event new player join game event. Pass the player and this for the game. And now we want to actually create the logic for our join mechanism. Since we're using an event-driven approach, we need to create event handlers, and we do that in our listeners package, which I've already created. And in there I'm going to create a class called game listener. This implements listener from org.bucket. And don't forget to register the listener. Inside the onEnable method, do get server, get plugin manager, register events, new game listener, then pass messages here. And for the plugin, type this. And inside here, we're going to start with the player attempt join game event listener. So event handler, public void on attempt join, player attempt join game event, then get the game, event.get game, and the player, event get player. And then inside here, we want to do a few checks before we allow the player to join. So specifically, we want to check if game is not full, if the game has not started already, and if the player is not already in this game. So let's start by checking if the game is full with game get players.size. This is the current amount of players in this game. And we check if this is greater or equal to game get settings get max players. And if this is the case, this means that the maximum amount of players has already been reached and we don't want to allow the player to join this game. So to disallow a join, just do event set cancelled true, and then we can send the player a message. And for that, we're going to use our custom created messages API from episode number 2. And to get an instance of that, simply do private final messages, and use Lombok to create a constructor for that. So required args constructor. Then inside here, we're going to send the message with player send message, messages get message. And now we need to create a new message type. For example, game not joinable. The path will be game not joinable. And now let's create the message in our config and let it say in red color, for example, you cannot join this game at the moment. Now get the message with message game not joinable and return. Now that's it for that. And now we need to check if the game has started, because then we want to disallow the join. And for that, we're simply going to add another Boolean expression here. So on the next line, do or, and now we need something to keep track of the game state, to check if the game is joinable or not joinable. And for that, we're going to use an enum. So in the games package, create a new enum, call it game state. Then we will have 3 states in here: in lobby, in game, and preparing. Preparing will be for a map reset, for example, or in general if the game is not ready yet. And then inside the game, we need to add the game state as an attribute with private game state, and the default value will be, let's say, in lobby. And we also need to create a setter for that with @setter. And make sure to assign this to UUID.randomUUID. Then in the game listener, check for game get state, and we want to disallow the join if the state is not in lobby. And now the last thing we need to check if the player is already in this game, because then we want to cancel the join attempt as well. And for that we need another helper method. So go to the game class, create a new method, public boolean has player, and with this method we will simply check if this game already has a specific player inside of it. So it expects a player parameter, and we're simply going to return get players.stream. And as you can see, inside this set we have game player objects, but inside here we have access to a player object. And to make those work together, we first need to convert those game players to normal players. And in this example you can do it with the map method, because now we're going to map the game players to their player objects. So for every game player, do game player get player, and you can actually shorten this with game player get player like this. And then we're going to look for any matches for any player P if p.getUniqueID is equal to player.getUniqueID. And this simply returns true if this player is in this game. Now back to the game listener. We can extend our if statement, or game has player, player. And then after the if statement, we are here if player can join the game, then we simply teleport the player to the game lobby location with player.teleport game get locations get lobby. And now let's go through this once more so you understand it 100%. Later we will call this method from our game manager right here. We're going to pass a player, and then this will fire a player attempt join game method. And we will call the event which sends this attempt join event object to all our listeners that listens for these kinds of events. In this case it's only this one. And inside here we're going to manipulate the event to cancel it if any of those criteria are met. And then inside here we check if the event is cancelled, if it is not cancelled. And in this case, if it is not cancelled, we add the player to our players list and we call the player join game event. And then in our player join game event listener, which we're going to create now, we will broadcast a message to all the other players in the same game that a new player has joined. So now let's create a new event handler, public void on game join, player join game event, then get the game again, event get game, and the player, event get player. And now we need a method to broadcast messages to all the players in the game. So go to the game class and create a method for that, public void broadcast, and we expect a component, message, and inside here we're just going to loop through all of the game players from the player set. And as said before, because we need to interact with players and not with game players, we need to convert those game players to players first. And in this case you can do it like this. First create a player variable, then inside an if statement assign it to gp get player, and if this player is online we're going to send the player the message. So player send message message. And of course you can also add logic to remove offline players from the player set if you want. Then in the listener call the game.broadcast message, and then we need to create a new message type for our join messages. So create a new enum entry, game join for example. Let's call the path game join message, copy it and create it in the messages.yml. And inside here we're going to use a blue color, then a placeholder for the player name, has joined the game. And then here we're going to give a quick overview of the current amount of players in this game and the maximum. So players for the current amount and max players for the maximum amount. Then back to the game listener, get the message with messages.getMessage, then game join. And now we need to replace the placeholders. The first placeholder was the player name, so placeholder.unpassed. It was called player, and we want to replace that with player get name. Then the second placeholder was the current amount of players, so placeholder unpassed. We called it players, and this is equal to game get players.size, and we need to convert that to a string. Then for the last placeholder, this was the maximum amount of players possible for this game, so placeholder unpassed, we called it max players, and this is equal to game get settings get max players. And we also need to convert that to a string. So select rep using string.valueOf. And now for the last things for our join logic, we need to call this join method from our game manager. So create a new method for that, public void join. We want to join using a game and a player, and then simply call game.join player. And now the only thing missing is a command to join. So let's create it in our arguments package, create a new join game argument. It needs to implement argument executor, then implement the methods. The usage will be join the game name, and the description will be join a game. The final command will look like this, /SkyWars join game. You can see it has 2 arguments. So let's check if the player entered the command correctly with if args.length is less than 2. Then player send message. Now we need access to our messages object, private final messages, and use Lombok to create the constructor. Then messages get prefix, append, and we're going to append the message as a component, component.text, and then pass the correct usage. Usage SkyWars join game in red color. So named text color red and return. Then we need to get the game by the name that the player entered here. So we need a reference to our game manager object, and with Lombok you can just create the attribute here, and this annotation will automatically update the constructor. So private final game manager, and then get the game with final optional game, and this is equal to manager get game, and pass the game name here, which is saved in args1. Then we need to check if the game exists. So if optional game is empty, then we can copy what we have done here. So if the game is empty, we just send the player a message that an entity has not been found. The entity kind is a game in this example, and the name of this game is saved in args1. And then we can get the game, final game, this is equal to optional game.get. Now we can join with manager.join game and player. Let's register the join game argument in the SkyWars command class, arguments.put join and new join game argument. We need a messages and a manager reference. And now let's create a game with a lobby point that is here. SkyWars create game 1. And now let's try to join that. SkyWars join. Let's first enter an invalid game. Game test not found. Now let's try with the real game name, game 1. And you can see we get teleported to the lobby, and we get our join message with the correct amount of current players and maximum players. And if we try to join again, you can see that this also does not work because we are already in this game. Now let's handle the logic to leave a game. So let's go to the game class and create a leave method, void leave game with a player. And inside here we're going to remove the player from the player set because we have a player here, but in the list we have game players. We cannot just do players.remove. In this case we need to do remove if, and then check for every game player if game player get unique ID is equal to player.getAUniqueID. Then in the game manager, let's create a leave method. So public void leave, and this time we only expect a player parameter. And now we're going to iterate through all of the available games and then just leave the player from all of those games. For game from games game.leave game player. Then in the leave game method we need to check if a player got removed. So as you can see, this remove if method returns true if any element was removed. So if a player was in this game and is now being removed, the return value of this method is true. So final boolean removed player. Then if removed player, then we're going to call the player leave game event. So let's create it, player leave game event. This extends from game event. Then create the constructor and call the event here. Bucket get plugin manager, call event, new player leave game event. The player is player and the game is this. Then inside our game listener, we're going to create a listener. First, we need something to call this leave method from the game manager, and we want to do that if the player leaves the server. So listen for the player quit event, public void on quit, player quit event, and then simply get access to the manager, private find game manager, and do manager.leave event get player. Now we listen for the player leave game event, public void on game leave, player leave game event, And from here we can just copy this, then create a different message type. We want that to be game leave. The path should be game leave message. Now let's create the actual message in the config. And from here we will just copy the join message and change the word from joined to left. Now let's change the message type from game join to game leave. Player get name, left the game. And then in the main plugin class in unenable, we need to change the parameters of the game listener, because now we also expect the manager. And then build the plugin. And now you can see joining still works and leaving also works now.